Do, 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 do. Do, 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 do. Oh man, been a long time since I used this thing. Do, do, do. All right, there's audio. Look at that. I'm gonna do a couple audio checks here. Oh, that's loud. Okay, cranked it down a bit. Let's give that a go. That sounds pretty good to me. So if you are in Discord, let me know if that sounds good to you. I'll do a poll. Too quiet for you, huh? All right. Let's crank it up a little. Blow some eardrums out. Probably adjust my camera too so you can see more of my head. Gonna take the poll again. Oh, I forgot to copy it. I have to retype it. Welcome everybody. I'm doing a little renovation here, so it'll be a bit of an echo for the first couple days. But if you joined me last semester, you'll notice I've cranked up the lights a lot. Okay, sounds good. I'm going to turn off my own echo so I can hear myself think. All right. Yeah, let's get started. Let me see how many viewers I've got, see if everybody's tuned in. Yeah, you know, I'm actually going to make an announcement to Canvas just in case anybody's not in Discord yet. And you can just go ahead and ignore that if you are already viewing. Okay. Canvas announcements seem to be down. That's a bummer. Oh, never mind. Just took a while to load. So go ahead and subscribe to the YouTube channel so you don't have to go through Discord every time. It'll just notify you when the video goes up. I also want you to subscribe, obviously, because if I get another 9,902 subscribers, I can quit my job as a professor and become a full-time content streamer, obviously living the dream. So yeah, please mash that like button, not subscribe button, and whatever else YouTubers say. But seriously, it's a little convenient to have that subscription in there. So let me see again how many viewers we have. This class is going to be about 15 people. It's actually one of the smallest 270s we've had in a while, which is great for you because it's kind of a hard class to Well, I have some old students in the YouTube chat. That's pretty sweet. Welcome again, guys. Why don't you tell the people who are still new how awesome it is to be in 270? Someone's telling me that being a content streamer is not a reliable pay source. You telling me I can't live off that 75 cents a week? Come on. Okay, looks like we have about 15 concurrent subscribers, so that's fantastic. I think that's pretty much everybody in the class. The rest of you, you just skip ahead anyway. In fact, you've probably already skipped this part so you could get to the good stuff, the reading of the syllabus, which is really what you're here for, right? That's why you show up on a school day, so you can listen to me read the same words that I'm going to read every semester that I've been online. Anyway, here we go. Let's go through the syllabus real quick, and then we'll actually get to some content today. Somebody humble bragging in the YouTube chat that they get 50 cents a month off YouTube. That is incredible, and congratulations to you. That's like tremendous. 18K subscribers. That's very good. Everybody go subscribe to that person's channel to give them, 15 more subscribers or whatever so they can get another quarter. All right, my name is Dr. Gurari. It's pronounced like Ferrari with a G, so Ferrari, Gurari. Nice to meet you if I haven't met you already. Just a couple disclaimers in advance. So I was raised on the old internet, the kind where nobody's nice to each other. So I apologize in advance if maybe I use a little bit of language that's maybe a little harsh sometimes. It's still something I need to get used to. I've had about a year, a couple semesters now to get used to it, but to me, the internet is still not a place where people are generally nice to each other. So sorry about that. This is going to be at least partly an online class. You can tell I copied the syllabus slides from a previous year, but oh, and I forgot to mention the actual syllabus, the PDF version, is available in your files on Canvas. So if you want to read along in the not slides version, that's where all the juicy details are. So check that out. So this is going to at least be partly an online class, at least till the 7th, and then after that we'll see how it goes. That means that there's going to be a normal amount of work. You're going to learn things. It's going to be possible to fail just like it is with a regular class. So don't treat it like it's, nonsense just because it's online, and, might end up being back in person. Anyway, so as long as we're online, I'm going to deliver lectures by YouTube. Since I've already taught this class online before, you can actually go ahead and look ahead on the lectures. There are some changes this semester to the content, but all of the lectures from last time are still going to be useful to you. I'll post the streams to Discord when they start in case you don't want to subscribe to me, but again, why wouldn't you if you want to really help me live that dream of becoming a content streamer? Class chat, all the group work and everything is all going to happen over Discord, so if you're not on Discord already, make sure you join it. The link is at the top of your syllabus. You can also comment on YouTube live chat. I'm going to be reading both as I lecture, but also obviously be aware that the YouTube live chat's open to the public. None of these videos are private. That also means trolls can come in, but whatever, trolls can troll. Assignments are delivered through Canvas. Watch out for those due dates. If we do go back to being in person, it's going to be your responsibility to work with your group. I'm going to talk more about how absences are counted and group work is counted and all that later. But basically, if you want group to be all remote, go ahead and do it. If some people want to come in, go ahead and do it. Just work it out with your group. You're not absent as long as your group says that you aren't. So as long as they're working with you in one way or another, I don't care how you set it up. As long as they're aware of it and everybody's happy, I'm happy. If you aren't physically present, though, you should at least be in Discord, just so I can communicate with you and get all the info you need. So, to reach out to me outside of class, or even during if you want, you can email me. There's my email. I'll typically answer within the same day. I am available outside of office hours at that email. You can send me your code or your writing, and I'll read it, and I'll get back to you. It's snippets, so it's much more helpful than trying to talk to me about it, where I can't really give you that much info on the fly. You can also DM me on Discord. I have a role. I'm the real professor, so last semester somebody thought it'd be cute to also name themselves professor. This time, you're not going to fall for that, right? I'm the role, actually the professor, and no one can take that from me, so just DM me on Discord if you have any questions as well. Usually I'll respond to you within a few minutes unless I'm in class or I'm in office hours with somebody else. I keep really weird hours, so don't worry about messaging me at 4 in the morning. I don't care. So office hours this semester, and this includes when we go back, those are all going to be over Discord. I'm not going to be in my physical office that much this semester. I might not be there during office hours. I'll try to be occasionally, but no guarantees. So if you want to come for office hours, You're going to join Discord. Again, see that address at the top of the syllabus. See the hours at the top of the syllabus as well. Just go into the office hours text chat and make any post, something like this. Here, I'll do an example. There you go. That's any post in the office hours chat. Due to the 10-second delay on YouTube, you're going to be confused as to why I typed on 10 seconds ago, but don't worry about it. And I'll just DM you and answer your questions or whatever you want to talk about in the order that I see them. And again, you can always ask an open question too in one of the chat rooms, and I'll try to get back to you there as well. You can always @me in your group chat if you have something you want the whole group to see. Most of you know how Discord works. All right. So again, class Discord lets you contact me, contact each other. By this point, most people are probably familiar with it. But if you're not, feel free to let me know and I'll give you a tour. We're going to use it for all of our chat functions. If you're not familiar with it, remember you can install it on your phone, but you should really have a headset. If you don't have a headset at this point in remote learning, that's got to be some kind of achievement, honestly. I mean, how can you not have one at this point in the process? So please get a headset with a microphone. Don't let us listen to your open mics with like babies screaming in the background and all the neighborhood dogs barking and loud music and everything else that you have going on. Just buy some headphones. They're like $20. Use your AirPods, whatever. Audio is usually pretty good on your phone, although sometimes it's kind of wonky picking your input device. But use whatever you can get good audio on. You can ask any kind of questions you want on the Discord. You can ask if the homework's due, if there's an exam tomorrow. Your peers are probably going to answer you in real time, faster than I can. And of course, you can ask questions about the class from me, peers, etc. You can also post and consume dank memes. I do not take any responsibility for the messages in Discord, no matter how spicy. All right. So don't spam the chat, don't spam the Discord. Use push to talk if you have a lot of background noise. Feel free to have side conversations in Discord during lecture. I don't care if you join the voice channels and talk to each other and make fun of the live stream, by all means. If you need to join late, just do it. I'm not going to notice. Especially not on online platforms. Just do it silently. You don't have to DM me or something and tell me that you're going to leave. That's fine. And that goes for if we go back to in person too. If you need to head out early or whatever, just go. You don't have to let me know. You can email me to let you know what you missed, and if you miss an exam, obviously that's going to require advance notice and some kind of documentation, but besides that, I don't particularly mind. So this is a group work course. Exciting, right? Everybody loves group work courses. That's why this is everybody's favorite. Historically, that's not necessarily true for everyone, but surprise, surprise, most software engineering is not done by yourself in homework-style format. So this is the course that teaches you how to develop software while working with others. You're going to learn how the software development process works as part of a team. We're going to learn the agile model, not so much the waterfall model anymore, but we'll refer to it a couple times. We're still going to divide our process into some discrete phases so you can learn about them, but in the modern age, most software development teams actually combine all these phases and pretty much do them all at the same time. We're not going to do that just because you're learning, but it's something to keep in mind. So we'll do estimation, requirements, design, testing, integration, and more. This is a no-risk environment. You're going to get a project that you have to do, but your customer is simulated, right? And so if you don't deliver to them, nobody's really unhappy. This class involves a lot of simulated pain. That is to say that your customer is going to be irritated if you don't deliver on time. They're going to make demands of you. But at the end of the day, there's no risk. You don't have to actually deliver something to this customer at risk of losing your job. So this is a great low-stakes environment for you to suffer a lot of the pain of software development without actually suffering the pain of software development. So take advantage of that. Don't take it too seriously, but you will probably at some point run afoul of that. All right, individually, you're also going to teach yourself a programming language as we go. That's kind of like a side track to this class, and then you're going to present it to the class at the end. And this fulfills the oral presentation requirement for the CS major. So in about probably next class, I'll put up the assignment that lets you pick a language. There'll be more details on that, but basically everybody picks a language. You're going to do a few tasks about it and so on and so forth. We'll talk more about it in a second. Every few weeks, the main project is going to go to a new phase. You're going to get a completely new team. So don't bother trying to work with your friends today because they're going to be gone in a couple weeks. In fact, the good strategy, if you have any friends or more than one, is to kind of scatter them out so you can work with them in different teams. But seriously, Don't worry about it. You're going to work with everybody at some point. You're going to get a new team every couple weeks, new teammates, different project. So don't worry too much about picking your first team. You'll work with almost everybody. And you'll work on almost every project as well. In fact, with this smaller class size, I think that you will actually work on every project. You might even get to work on a couple of the projects twice. We'll see how that turns out. Read the learning outcomes in the syllabus at your leisure. Read the program goals at your leisure. Course materials, well, your team can use whatever software they want, so your team might use a variety of software. Make sure you have a machine where you can install software. If you're trying to do this class on a Chromebook, you're going to have a bad time, so reach out to IT to get a real computer. There's an optional textbook. Definitely don't type Software Engineering Somerville PDF into Google and then click one of those links there that contains a whole copy of the textbook, because that's piracy and that's wrong. You should definitely go to the bookstore and pay full price for the Dead Tree version of it, because it's the right thing to do. But we are going to use the slides from that textbook primarily. It is still essentially the book on software engineering. And so it's a really nice reference to have, especially if you don't want to listen to my presentations. In lieu of listening to the slides, you could just read the chapter most of the time. So you can use the CSVM if you want. That's basically all I'm going to say about that. Good luck if you do. Homework and in-class work, most of your grade here is the homework and the in-class coursework that you do with your group. Typically you're going to get at least one per week, but usually more. You're usually going to get one per day. Everything moves pretty fast, so late assignments generally not accepted. If you anticipate being late, let me know, but usually by the time you're late, we've already moved on to the next thing, and stuff's going to pile up, and sometimes your assignments go to peer review, and I can't really delay the other team looking at it, so basically you have to be on time. Sorry. For the language project, you can let me know if you need an extension. I'll be happy to give you that. The late penalty is at least 10% a day. Homework's only accepted through Canvas. Please don't try emailing it to me. Follow the instructions carefully whenever it tells you how to submit something on Canvas. Most things require just one person to submit, but read the requirements. Occasionally, I'll have you submit something individually. For code submissions, I'm always going to have you submit a zip of your source code in whatever the appropriate format is. So you might not use Java, you might use any programming language. Who knows? Somebody asked, how do I code? And I don't know the answer to that. Homework reading. Follow the assignment description. Make a meaningful attempt at doing what's asked, and you'll do fine. Some of the homework, some of the assignments that you get are going to seem crazy to you. It's going to be like, how could I possibly do this? Well, the name of the game in this class is do your best, make an honest attempt, make a good shake at it, and contribute to your team. And I assure you, you will get at least a B. So try to do what was asked, make a good faith effort at it. Grading is mostly relative. You don't have to be perfect. You just have to do about as well or better than everybody else. So basically, you're trying to hit that sweet average. Just do what was asked, to the best of your ability, and you'll do well. But for the best score, make sure that you read the slides, do external research, try to submit something that's closest to what you think my expectation is going to be. Don't just, read the assignment description and then try to intuit everything without actually having paid attention to the lecture, looked at the book, read the slides, or done any kind of searching on the internet. So the book helps a lot here as far as references go, because it has pretty pictures. Quizzes, we don't have any. Labs, we don't have any. Exams, we have midterm and a final. See the schedule for the dates. They're going to be through Canvas. Expect multiple choice questions. More details on that as we go. As the past students who are in the YouTube chat will tell you, the exams are awful and everybody does bad. Same as the exam for the final. Okay, so attendance and freeloading. This is very important here. You're going to get a score that reflects your participation with your group, your contribution, basically. You're expected to be in Discord with your group or with them in person if we go back, working whenever class is in session. If you miss a class without informing your group, you're going to incur an absence penalty. You need to make arrangements with your team if you're going to be absent. If you miss a lecture, that's fine, just watch the recording, or if we're in person and you don't have a recording, tough luck. I guess just ask me what you missed and I'll direct you to the book. Groups will review their peers at the end of every phase. This is the important bit. And you may see a reduced final grade in this class, maybe even a significantly reduced final grade in this class if you do significantly less than your fair share. But you also might see a bonus, maybe even a significant bonus, if you do less, or more than your fair share. So try to make an honest contribution. I will give you some warnings around the halfway point that maybe you're not contributing as much as you should be if you're in that category, and vice versa. I'll let you know if you're contributing so much that people think you're great. You might say, well, isn't this just a personality contest? And to some extent, yeah, well, so is life. But also, this is kind of the ideal environment for having a personality contest, isn't it? Since essentially everybody in this class is probably a stranger to you because you've probably never met in person and probably haven't really interacted online that much. So insofar as you're worried that people are going to rate their friends highly and rate you down, well, that's pretty unlikely. The only way that's going to happen is if you, by random chance, get into a group where somebody is with their friend every time and chooses to do that. The odds of that happening 5 or 6 times in a row is pretty low. And most people don't exactly have an abundance of friends at this point. So here's your opportunity to make some. Enjoy that. But anyway, be the kind of person that people want to work with, and you will do well. I think that's pretty much universal in all the times that I've taught this class. If you act like a responsible person and people want to work with you again, it doesn't really matter how knowledgeable you are. It doesn't matter how good at programming you are. What matters is that you try your best to contribute and make it seem like you're trying your best to contribute. Final grading is going to be weighted by assignment group. The main project is the biggest part of your grade for this class. The little small language project is worth 20%, and the exams are worth another 20%. Everything in Canvas will be weighted correctly, so you can calculate your grade as you go from there. Somebody asked if pineapple goes on pizza, and the answer is definitely yes. You could check the syllabus for the calendar. That Easter break thing doesn't apply anymore, actually, so forget about that. We're back to normal stuff. And as far as cheating goes, you can copy the book, you can copy your own older work, you can copy anything I give you without citation. You can copy anything that you find on the internet that's free of copyright or other legal restrictions as long as you properly credit it. You probably won't do that great if you copy stuff from the internet and lightly modify it, but some stuff on the internet is okay. It's just difficult to figure out what. Anyway, the only thing that you really can't copy is one another, and of course stuff from the internet that you didn't properly cite. But since all of your projects are completely different, the point of copying each other is pretty low, so that's probably not going to be an issue here. But obviously don't do it, and don't copy each other for the language project. But again, you'll have different languages, so that's probably not going to be an issue here. Go ahead and read those disability statements and whatnot at your leisure. Big picture, be respectful to your classmates, get on Discord, make friends, ask questions, don't fall behind, do your homework. Email me or DM me if you're stuck, and just be a good teammate, and you'll do great. Someone asked if corporate espionage is allowed. Yes. I don't know what that means, but go for it. You can steal ideas from other teams and make them your own. Right. Now that that's over with, finally, good old syllabus slides, so much fun. Let's get software cost estimation, the meat of today's discussion. Let's talk about estimating software, and then we're going to get into the chats, and you can form your teams, and we'll start on today's assignment, the very first one. Oh boy. Okay, software cost estimation. Why is this in such a small window? That's not what I wanted. Full screen doesn't cooperate. Oh well, good enough. Just roll with it. Yeah, that's fine. You can see it. That's the important thing. Okay. So, and you can answer this in Discord or YouTube if you want. What's harder, do you think, to estimate? Physical engineering, like civil engineering, like building a tangible thing, like a house or a bridge or a road or whatever, or software engineering, which is basically building an idea, right? You're not building anything physical when you're software engineering. It's a bit like art versus engineering. So some people are saying software, and those people are probably software engineers. And I think that the mechanical and civil engineers out there would probably disagree with you. But let's think about that. Why is software harder to build? Or why do some people think that software is harder to build than physical stuff? So first, let's say, why bother estimating? Well, if you're working for a third party, which most software companies are, well, let's not say most, but many software companies are, then of course you need to bid to win contracts. And when you're making a bid in a society that has commerce, you're estimating that it's going to cost you less to finish it than you're going to make in revenue from the contract. And that means that if you bid too low, you don't get the contract and you get no revenue. And if you bid too high, then of course you end up if you bid too high, you don't win the contract and you get no revenue. And if you bid too low, then it costs you more to finish it than you get back, or you don't finish it so poorly that you don't get paid at all, and then of course you go out of business. So no contracts, no revenue, and bad at estimating means no profit, and no profit means no business. And of course, if you're not trying to capture third parties, if you're a software company that's developing your own stuff, as also many are, maybe most are, well then you still need to estimate accurately to gauge your own time. You're essentially just winning contracts against yourself all the time, and you need to decide, well, is this expense going to pay off? So there's the business side of it, where you calculate the amount of revenue that you're going to make, and that's a mystery too. But then there's also the software side of it, where you're trying to figure out how much it's going to cost you to build this thing, and that's obviously a very important part of the equation. So software estimates, even at their best, are terrible, and this is true even for experienced people in the industry. In fact, software is way worse than basically any other industry at estimating. The industry routinely sees projects that are never finished, so by some accounts, at least a quarter of all software that's started is never completed. Around 15% of all the software projects that are started never deliver anything at all, so not a single tangible piece of delivered product. And this is true for contracts of all levels, from the thousands to the millions. So many software projects end up costing millions of dollars and giving you nothing at all. The other things that are also very routine in the industry are projects that double their expected costs, or double their expected schedule, or triple or quadruple those things. It's very typical to be over budget, behind schedule, and never finish. In fact, only a minority of projects are a success by most meaningful metrics, in the sense that they come in under budget and ahead of schedule. Some would argue that that's not a bad thing, that it's better to be that way than to consistently be under budget and ahead of schedule. You can ask the business school people why that is an argument that some people make. Here I like to cite Parkinsons Law. Parkinsons Law says that work expands to fill the time available for its completion. This is something that we probably know from our lives as well. That is, that estimates will become self-fulfilling prophecies. Let's say that you say, I'm going to finish this homework assignment on Saturday, and I'm going to give myself 2 hours to finish it. Well, guess how long it's probably going to take you? At least 2 hours. Whatever time that you budget for yourself, you're probably going to consume it, regardless of whether you need it or not. That's just kind of a human instinct. And this is also applicable to things like work meetings and course exams and so much more. Like, when do you finish an exam early? Do you think that professors sit there meticulously estimating the number of seconds that each question is going to take you? Nah, we just vomit that stuff onto the exam sheet. Just kidding, it's very careful. But regardless of how long or short we make the exam, somehow almost everybody in the class always sits there for the exact amount of time that the exam takes, right? Very few people leave early. And a lot of things work that way. People just sort of fill the time that they have. That means that when you make an estimate, well, it tends to take you at least that long. And then at a certain point, you run into the next rule, which is the 99 rule. The first 90% of your software engineering project, well, that's going to take 90% of the development time. And then the remaining 10%, that's going to take the other 90% of the development time. If you didn't get it, read it again and do the math. Just don't add 200, and that is on purpose. That's not a typo. So the first 90% takes 90% of the time, and then that last 10%, the part that was supposed to be easy, that takes the other 90%. Just when you think you're almost done, you're probably about halfway there. Keep that in mind as you go through your projects this semester. When you think you're almost done, you're probably about halfway there. All right. But why is it so hard to estimate software? Well, it's very difficult to compare to similar works in software. More on that later. Non-engineers tend to underestimate the complexity of software. I think we're probably familiar with that already. People just think you make the funny lights and the machine go blink, blink, boom, boom. Deadlines actually make work harder to do. Deadlines create stress, and deadlines create expectations, and deadlines also create the effect that you get from Parkinson's Law, where work just fills the space it has available, like a gas fills a balloon. Complexity doesn't grow linearly. Making something a little bit harder can require a lot more work. So adding a small feature can sometimes exponentially increase the amount of work that you have to do. The size of the project is difficult to estimate upfront, and the skill required to complete the project is difficult to estimate upfront. There's a lack of a template in the industry. If you're building houses, well, we all know what houses look like. Like, what do developers do to build housing, whatever you call them, neighborhoods at cost? They just build the same house 100 times. You get to pick between 3 different templates or whatever, and they keep building it. When you built the same house 20 times, you probably know about how much it's going to cost or how long it's going to take. Maybe it's a little bit different because your environment's a little different. You got to level the soil a little or something. You know, obviously environment is a challenge when you're building physical things, but you have a pretty good estimate of how much the house itself is going to cost you relative to the market price of the physical stuff that you need to go into it. But building near identical software on near identical technology, well, people just don't do that because why would you? If there's something already out there that does the exact same thing, generally speaking, most customers don't want it. They'll just go buy that thing. Unless there's an issue with the pricing, and for some reason they've decided that building it from scratch is cheaper than buying it, which is generally not true, and also generally not how most customers buying software think. Now you might say, well, okay, I'm going to come into the market as a competitor to another software. I'm going to do what they do better. Well, okay, maybe you can figure out what it costs to do the same thing that they did. You probably can't because it's not like they make that information public, but let's say that you can. Well, how do you know how much it's going to cost to then make it better? It's not like a house where just making it slightly bigger, adding another room is pretty obvious. No, it's more like the house is already built and you want to completely overhaul the HVAC. Well, pretty difficult to get an estimate there. Marketing folks want to make sales. Marketing folks don't want to say no. They want to say, we can do this. And what they mean by we is you, other software developers, not marketing people. Marketing people don't actually build anything. They just sell things. So someone can build it, but not us specifically, just other people at our organization, us. The people buying and selling the software are, in general, not the people who write the software. That means that the people who are estimating how much time it's going to take aren't always the people who are actually going to be writing it. Bid in January, done by June, right? If there's a deadline, well, we need to meet the deadline because business says we need to meet the deadline, so then we crunch. And when we're crunching, we make mistakes because when we rush, we make mistakes. Haste makes waste, right? Mistakes cost time. Mistakes cause us to build up technical debt. And of course, technical debt builds up easily, but takes a long time to clear. Missed deadlines lead to more crunch. More crunch leads to more mistakes. And the cycle continues. Complexity grows exponentially. Sometimes software grows 2 times in size, but it might grow 4 times, 8 times. You pick your multiple in complexity. It's very rare for software to grow twice in size and grow less than twice in complexity. Generally speaking, any increase in complexity is going to lead to, any increase in size is going to lead to a much higher increase in complexity. And measures like lines of code are already a pretty poor measure of complexity. So how do you measure complexity in the first place? You can't really measure it by the size of the software. Something that launches a satellite to the moon is probably more complicated than, I don't know, a simple website, but which one has more lines of code? That's a crapshoot. How big is a project? When someone asks for a house, again, we know how big they want it up front. They're going to tell us the square footage. They're not going to say, I want a house and I want it kind of, you know, some size. And then you tell them a square footage and they go, we'll talk about that later. Why don't you just build it first? And then we'll decide how big it should be. No, for software, even guessing at the size of the project is an estimate. You don't know how big it's going to be when you start. And something that sounds really simple, like write a program that tells me if there's a cat in this photo. Well, that sounds like it could be done in an afternoon if you're an experienced programmer. Well, it turns out that's millions of dollars in development right there. That's a really hard problem. So sometimes something sounds very simple, but it's not. Keep that in mind when you read through the project opportunities that you have available to you this semester. You don't even know how good your team is. often when estimating, you don't know who will be working on the project even. You don't know what the skills are of the people that are going to be working on the project. Maybe you haven't even hired those people yet. You certainly don't know in this class, do you? You don't even know what teams you'll be working on in a few weeks. No idea. What technologies are they good at working with? Carpenters, they vary in performance too, but you can be pretty sure that most carpenters have some shared skills. They know how to measure pieces of wood and cut them and nail them together and that kind of thing. So there's really not as much variance in performance as there is with carpentry. There's no so-called 10x carpenter, the carpenter that does the work of 10 other carpenters. Unless you have 10 very lazy carpenters, the best carpenter can probably do about the work of 3 low-skill carpenters in the best case. So let's talk about a couple ways that you might estimate the size of your projects. We can use person months, weeks, days, hours, whatever you want to use as your time measurement there. That's about the amount of work that a single developer can do in 1 month of full-time work. You can consider it 1 month of whatever the normal amount of contribution to class is. So obviously you're not going to work 40 hours a week on this class. One of the most important books in software engineering is The Mythical Man Month. Read it or skim it if you get a chance. That describes the myth of the man month. And most importantly, it makes the point that adding people to a project does not necessarily make it go faster. So if let's say 10 developers can finish something in 10 weeks, it is not true that 100 developers can finish it in 1 week. In fact, it might be the opposite. If 10 developers can finish it in 10 weeks, 100 developers might finish it in 100 weeks because adding people increases complexity. The metaphor that's often used is that you can't make pregnant women deliver a child in 1 month by having 10 of them. 1 pregnant woman delivers a child in about 10 months. 10 pregnant women don't deliver a child in 1 month. That's just not how the scaling works there. So throwing people at a problem is not necessarily the way to go. You can also estimate in dollars, but remember that a developer is much more than their salary. The true cost of a developer, including benefits and all the crap that they need to do their job, is often 2 to 3 times what they actually get paid. Of course, that's what your employer tells you, right? Secondary costs can be very high for developers. So start similar, and then go different. Ask the team if they've had experience with similar projects, or at least parts of similar projects. What did those cost? How were those projects similar? Did you have the same kind of team with the same kinds of skills? Are you missing any of the skills that you're taking for granted? Then talk about the differences. How's this project different? And what will those differences cost? What's the impact of those differences? What expertise are we missing? You might want to create a conceptual design, break the solution into parts, try to estimate the price of those parts. But don't confuse that with software design. That's going to come in a few weeks after you've won the bid. You could make a distribution. This is always a good idea. Although customers don't necessarily want to see a bell curve, you can decide on how confident you are about each of your estimates and generate a bell curve for the cost and time that it's going to have. You do the average in the middle, make a probability distribution. The less confident you are, the wider your tails are going to be. There's a tool that I listed a link to there that's great for doing this, and it draws you a little pretty bell curve picture. So go ahead and make your bid that way if you want. I enjoy this format personally, but who knows if the customer will. You can do the wideband Delphi process. This is from Somerville's book directly. 6 steps here: planning, kickoff meeting, individual brainstorming, group estimation session, assemble your tasks, and review the results. So first, you're going to figure out the scope of the problem, try to break it into parts. Somebody's assigned to be in charge and run the meeting here. And then in the kickoff, that person will deliver the problem to the team. Everybody splits off on their own and estimates how long it'll take to finish all those different parts on their own. Then you come back together, share the estimates, average them out, meet again to review the results, and then you're going to basically repeat this process until you come to kind of a consensus about estimates. And yeah, the assignment's up, so you can start reading through them if you're done listening to the soothing sounds of my voice. If you want to do wideband Delphi, appoint a moderator to collect those estimates. Remember, you're going to do multiple rounds. So after the first estimate, if the moderator sees that everybody's in a completely different camp, if everyone came up with completely different numbers, you'll have a little session, you'll talk about it, and then you'll split off again, make another estimate, and then go back as a team and see if everybody's converged a little closer. So it's a crowd convergence algorithm. Those are very popular in computer science, aren't they? And the process ends after several rounds, or if you've come to convergence. So if you can't come to convergence, then you do your average. Yeah, somebody asked if the assignment is due at the end of class. Yes, it is. So you can start picking your teams if you want. But the assignment that's due is actually basically just to submit your names and the projects you decided to bid on, so you just get to talk to each other and figure out which ones you want. Learn from experience. Estimation is one place where unfortunately you rarely get the chance, but again, low stakes environment for you here, so the lesson is going to be cheap this time. It might be expensive if you end up having to do it in business instead. If you can get estimation experience at your job, take it, because it's a rare skill, and like all rare skills, it has value to employers. Anyway, without further ado, let's all roll into Discord. Join any of the group voice chats to pick your team. So we're going to try to do teams of 4, and if we have an overflow, then we'll go to teams of 5. So just go 4 to any chat. There are a bunch of group voice chats there. So just 4 of you in each room. Again, it doesn't matter who you group with, you'll be with everybody eventually, so don't worry about it. And your first responsibility today is going to be to read through the projects, pick the one you want, and I'll come and visit you, so if you have any questions for the customer about any individual project or just anything you want to know, feel free to ask the customer. All right, see you guys on Discord. Thanks for tuning in.